do. Alright, so one more time, short version. So anti-differentiation. If you do a derivative is doing differentiation, anti-differentiation is going backwards. I'm going to give you the derivative, and you figure out the original function it came from.
Yeah.
Not that hard. Okay, we are only going to learn how to reverse the power rule and go backwards. Okay, if you think about it, trying to undo a product rule, a chain rule, and a quotient rule could get considerably more complicated, which we'll save for our full-blown calculus class. So we're just trying to figure out how to redo a power rule and go in reverse mode. So I think you can look at this one, you all can reason it out, then we'll come up with the actual formula. If that's 6x squared, when I did the derivative, can you reason backwards and go, what would I have had to have done to get the original function?
What would your constant?
So it'd be.
Yeah, I have a 2x to the third.
That would be power 1. So that.
It has to be in square.
Oh wait, no. That's wrong.
That's right.
That's right. Yeah. It does. You divide by n plus.
That's right.
Would it be 4x squared then, the next one?
Yeah. You divide by n.
We have agreement. Is it 4x squared? Okay.
It's what? X to the third? No. Yeah.
What makes you get a constant number? Yeah.
It's something to the x.
It's just got to be 3x to the first power, because then the derivative becomes 3.
How we knew there was a number with an x.
Thank you, Simone. Did you all hear what he just asked me? How do you know there wasn't another number whose derivative became 0?
We don't. Oh, because it goes 4, 3.
Because the derivative of a constant number is 0. So we have that issue of there could have been plus 7 out here or plus 42. We don't know because its derivative would become 0. So consequently, we always on the end of these throw a plus c on there for some unknown constant that could be out there.
But it could be minus.
Okay, c could be a positive number or a negative number. So we just receive. Now, what I want you all to do is, you figured it out, turn it into a process. What did you do there to get the 2x cubed?
We took out the 3 and
We divided it by.
Because did you all think first, what power will I have to have?
yeah.
Because if that was a 2,
Divided by the exponent.
and so then I took the number out in front and divided by the old power or the new power? By the new power, yeah. You added 1 to the power and divided by that same power. So try that on the 8x. If I add 1 to the power, that will give me 2, and if I then divide by that power, I get the 4. And technically on this one, adding 1 to the power gives me x to the first, because technically that was x to the 0 to start with. So I would be dividing by 1 then, and that would leave me with 3x. So congratulations, you just discovered the power rule. Okay, while I titled this anti-differentiation, it's more commonly known as integration. When you start talking about what it means in terms of a graph. So I will have a hard time, I will try to call it anti-differentiation for a while until I tell you what we call it integration when we actually know what it means in terms of a graph. Okay, so the power rule you just discovered though. Okay, the symbol to say go backwards, you were noticing a strange looking, it's a long skinny S is what it is. And I'll eventually get to why is it a long skinny S?
There's a line with 2 hooks on it.
Okay, when they actually give you the problems, there'll be that's called the integral sign. They'll give you the sign, they'll give you whatever function they want you to do, and there will be tossed on the end of it, it'll be times the x. That means you're doing this in terms of x. And let me remind you, if I give you something here, one of the notations for derivative was the derivative of y, we wrote dy over dx in terms of x. we did the derivative. All they're doing is they're simply multiplying this dx over to the other side when they give you the problem. It all comes from the derivative notation. You aren't going to do anything with that dx. It just says, hey, dude, we're doing this in terms of x. It's declaring what variable. You can do problems in multiple variables. We won't be going there.
At least not this year.
I go there just a teensy bit with, as far as we get in calculus. Multivariable integration is a whole other world. Multivariable derivative, sure, we do them. But going backwards with integration, that's up the ladder. That's why you take a class for your fourth semester called differential equations.
3 or 4 semesters?
The fourth semester. Yeah. So when you see that dx for right now, you all aren't going to do anything with that dx. Eventually we do something with it, but for what we're doing, no. And then all you have to do, you just told me the rule was do what to the power? Add 1 and divide by that power. So add 1 to the power, divide by the power. The key thing, it's increasing the power. Integration increases the power. Derivatives decrease the power. It's the number one mistake I see on this test. People get it backwards. So, increase your power. I for integral, increase. Okay, and the funky little long skinny S's are kind of fun to draw.
So on the integral, you want the whole thing or just like the x to the n times?
Where I asked you to list the power rule?
Power.
I want that whole thing, what you start with and where you go with it. If you can't see where you start with, it doesn't make a lot of sense. So, all right. So, you look at this problem. You should first look at it and go, they want me to go backwards here. I'm going to increase my powers. I'm going to get back to the original function. This is the derivative. Are all those terms in the position they need to be in order to do this?
The fraction needs to be brought to the top.
Yeah, you got to have all your x's. It's just like power rule for derivatives. You have to have all the variables have to be up top, and it has to be added, subtracted. You cannot do power rule unless you have addition, subtraction. You can't do it with multiplication or division. Excuse me, could you stop talking through this, or you could go take yourself somewhere else if that's all the more you're going to pay attention to me. You're a person who's not in great shape. I would suggest you tune in. Okay. So, all right, when I bring this up, what's it become? 6. Notice you can't bring the 2 up. You can't bring the coefficients up. That 2 stays down. That's 1/2. Don't bring it up. And then this is x to the what? 2/3. Okay, now we're going to challenge your arithmetic skills here. Once you have all your terms up top, then you're going to do your power rule, and you're going to start adding 1 to the power. So what will this become? 8x to the 6. Yeah, we'll reduce it to 4/3 here. I'll come back and clean it up in a minute. Because I do add 1 to the power, divide by the power. You wouldn't have to put it under the 8. I just put it under all of it.
The next one's going to be -5.
Yeah, -5 all over -5. We'll come back and clean that one up too. All right, this is the one I'm worried about. What do you get when you add 1 to the power? You have 5/3. Okay, so I should actually divide by 5/3. Do you really want to divide by 5/3? Thank you, Blake. Yes. when you do these ones with fractions, instead of dividing by 5/3, nah, just times it by 3/5. Way easier. Then you don't have a fraction in a fraction. That's ugly. Alright, then add 1 to your power would be minus 5x. And then plus these were the point on every problem. A whole point for the plus C's.
No matter what, you put plus C down at the very end, and you're guaranteed.
You should put a lot of plus C's.
Because we don't know anymore.
Every question.
Okay, I recommend at the top or the bottom of your test, you write a big plus C to remind yourself to go back and check when you're done if you put your plus C's on.
I usually don't have time to go back.
Limits, you have to write your limits, yes. Okay, on these problems where it's single terms, one that's just simple terms like this, I will ask you to simplify it. What would that reduce to? I go to 4/3, x to the 6. This would actually become, I got a 2 and I got a 5 on the bottom. Can I combine them? So it's going to become a positive 1/10. Okay, your choice. We can bring, actually I think on these kind I told you to bring it back down, so that'll become x to the 5th. This one, I don't care if you put it back in the root. If you want to, you can, or I'm perfectly fine. Most people just leave it as 5/3. It's positive power, so that's fine. And actually the rest of this is fine. It looks complicated. It's not that bad, really. It can look horrible, but it's really not nearly as bad as it looks. Considering some of the other stuff you've done, this isn't that horrible. So, let me see if I can throw you a few wrinkles with this.
I have a question. So how are derivatives and integrals related? Would it be that
Well,
whenever the next goes
they are opposite operations. Yeah, they reverse each other. Now, as to what integrals tell you about the graph, haven't got there yet.
We're gonna do that this year, or we're gonna do that next year?
I'm going to show you what it means this year, yes.
This year or next year?
If I have time, I'm going to tell you today. If I don't have time, I'm going to have the 3 seniors come let me tell them in 5 minutes, and then I'll tell you next time. Depends on time here. First, my bigger concern is for you to learn the process, because now you're going to look at this and go, but you just said we weren't going to do this. Okay, I just gave you 2 quantities that are multiplied, and I told you I wasn't making you reverse the product rule.
You just said you were gonna make me do that.
Okay, if it's only 2 binomials, what can you do with 2 binomials? Well, they are factorial. Oh, yeah. So if it's 2 small quantities, I would FOIL this one anyhow. That's the easiest way by far. So, yes, remember, you cannot do the power rule unless you have every term added and subtracted. So since this is multiplication, you cannot use that power rule. You will have to FOIL it. What do I get when I FOIL that? Thank you, x to the 7th plus 8x to the 3rd minus and then a minus 24x. Any like terms we can add up? No. Okay, you should keep your integral sign in front. That's a reminder that, hey dude, I have not actually added 1 to the power yet. I've not increased my powers yet. So now, are they all in a good form where I could do the power rule? Yeah, they're all up top, nice little positive powers. We like this. So, okay, what's power rule say? That's a derivative. So that's the power. Integrals increase.
Move the 7, add
X to the 8th, go up a power. Integration, go up a power over 8. And here, 8x to the 4th, or over 4, so we can reduce that. 3x to the over 6, and 24x to the 2nd, all over 2. Is that it? Thank you, plus C. And so then, yeah, I could go back and reduce a couple of these. 8/4 is really 2. 3/6 is really a half.
How do you get the 24x? How do you get it squared?
Add 1 to my power.
Oh, that's right.
All these, can we do divided by two, we have to do something.
Oh, no, you don't. You could pull out a factor, but they don't bother with that. Particularly after I get to what on earth we use this for.
So long S means what factor?
The long S is the symbol. Well, actually, I haven't taught you what it really, really means yet. Unlike with derivatives, I taught you the theory first, then we did derivatives. With this, I have to teach you the how to it, and then I can show you what the theory is and what it tells you. Yeah.
So you haven't told us any journal answers yet.
Not a lot. Yes, the dx chain is part of the notation for derivative, so the dx just disappears once you integrate it. It just goes away again. So you don't have to worry about that dx.
So how do you get there?
It came from doing the derivative. It came from the notation that if y equals 8x to the 7th, derivative is dy over dx. It came from the derivative notation, so it just goes away when you get rid of the derivative. If you have a plus 7, then when you integrate it, you'll have a plus 7x then. Because you'll have to... Yeah. Because technically, 7 is 7x to the 0. So when I add 1 to the power, I'd be doing 7x to the first over 1. So it just becomes 7. If there's a plus 10, it becomes 10x. Just over 1, yes.
You think we are in the top, even equal of the two we have in the, Madame. The first equation